Now I'm going to get you guys a little bit of help for this. So it says try to turn the problem to something you can solve. We'll deal with that in a sec because no one can solve a 3D triangle in their head, not even me. Okay? So we'll deal with that. And number 4 says draw a diagram. What will this diagram look like? Can anyone guess what? We're in trigonometry. What will our diagram look like? Go ahead. A triangle, good, okay. So you say, I don't know what this is going to look like. Start with drawing a triangle. That can get you started. I know some people are laughing, okay, right? But the number 1 question I'll get asked, I don't know where to start. And I'll say, well, unknowns and draw your triangle. And number 5, ask if your diagram makes sense. So a lot of the questions will say something like, Spider-Man is looking up at Venom. So what that probably means is that Spider-Man's on the ground and Venom's in the air, right? So if your question is Spider-Man swinging from his web up here, looking down at New York City, something's wrong, you know what I mean? Yes?
Would you recommend drawing multiple triangles?
And that's exactly what we're actually going to do for this. Yes, that's exactly what we're going to solve these. Yeah. Are you good? Great. Come back on the
Yes, the drawing of it though. Like,
definitely not.
You're not just gonna be like, because on the side you figure out for us. So.
That was only 1 question. That's 1 question will be like that.
We have to draw ourselves.
Yeah, well, you don't take a look at the, go back 1 question. Flip it over. So word problem at the bottom, that's what we will run the question like to. Okay. Yes.
So we said we're going to draw both in collect quadrants, but it's always going to be linear, right? Like it's never going to
Yeah. We'll show you guys how these all work. Don't stress out. Here we go. Example 1. Says a rectangular prism has length 10 centimeters. Width 8 centimeters. And height 5 centimeters. Find the body diagonal. I'm going to say in my picture it's going to be HG.
You make it so hard on yourself. You can do it such
I know, just, I'm not an art teacher. Okay, so there's A, B, C, D, E, F, G, H. Okay, so that's a 3D box. Now, if you don't believe me, that's what it is. What I'd actually like you to solve is from my 2 fingers here. Okay? So it's from the top corner on the left to the bottom on the right. So you see what I'm doing there? That's what we're going to solve, and we'll show you how to do it. So if you look at what I'm doing, here, right, it's from the top corner on the front, here, to the bottom on the back. Yeah, through it. Okay. I'm going to show you how to do it right now. That's what you have to go through it. Yeah, exactly. Going through it. So everyone see that? Seeing at the front is the top, on the front is the top, on the back, and at the bottom down. Okay. Got it? That's what we're solving. Now let's actually, I'll draw the picture here. That we call the body diagonal. All right, so I'm going to draw a picture. It's going to go something like this. I'll do it in green. So I'm solving from A to G, or not. Okay, so the question is here, how can I solve that? I can't do that in my head. If I'm looking at this, there's no way I can solve this in my head. Okay? Can anyone give me a suggestion, Luke, if I would do that?
First, you start with like an X or X and Z.
Okay? So I think what he's saying is what you can do is, if you turn the triangle just like this and ignore the depth, I can find that line.
Yeah.
Okay? Okay, so I can find that distance, no problem. Then from there, so that'll be one side of the triangle. Then from there, I will have the bottom of this covered. I'll find that distance. And if you use the height, right, so the bottom of this and the height, that'll form another triangle. Does that make sense? I'll draw it on here if I do it here. Okay, so what I'm going to do is I'll find the bottom distance from A to F, and then F to G, and that'll be a right angle.
No.
Got it there? Okay, right? So we'll find from A to F, and then F to G, and that'll be, yes?
Do you start with like an XZ and then go to an XY?
You could do that if you want to, but this is okay for right now, okay, for this. Let's get some distance here to make sure I got the length 10, we'll say that's 10. That's 8 and that's 5. I don't want to get too confusing for people. Let's just start with this for right now. Because I don't want to
the base and the height, and then the hypotenuse of the base.
Right on. Okay. Got it. Okay, so let's first of all start by solving. What I'm going to do is here. This is what Luke was saying before. I thought was a good idea. Let's just draw the bottom of the. Oops, maybe not. Let's draw the bottom of the box. So the bottom of the box is going to look something like this. Here's what I'm going to do. So we're going to have an 8 and a 10 and an X. Then from the side, it's going to look something like this. Right, so I totally am an artist. I totally am an artist. It's not very nice. All right, so here we go. So what I'm doing for this is then, what I did was 8 and 10, and I'm going to find the X. So you see what I did there? Right, just to go back to my Kleenex box. I just ignored it. Oops. I just found this right here, right? That's what I found, this part. And then I brought the third dimension by using the height then. Okay, got it? So that's what I'm doing. Okay, so, yeah, sorry. Yeah, so what the second triangle is going to be is A to F is the bottom of this box, right? So the hypotenuse is the bottom of this box, that's what A to F is. And G is just going to be up in the air then. Okay, so you're using like, instead of using like, you know what I mean, length and width, you're using the hypotenuse as the bottom of it, and then the height of 5. And then the hypotenuse of that is going to be. All right, so let's do this here. I can't do this in my head. I'm going to use square roots because I like square roots.
What is the principal term?
They call it the body diagonal property.
So what I say, like when I'm
X squared is 64 plus 100. X squared equals 164. X squared of 164. So I'm going to say then y squared equals the square root of 164 squared plus 5 squared. That's equal to 164 plus 25 is 189. Is that right?
you want it in square?
Either one works for me. Okay.
Okay,
Yeah.
so for the 164 in the square root squared,
Yes.
they just cancel?
Yeah. Because like you square a square root, yeah, it just cancels out there. And if you want to use decimals, that's fine too. I just might click note down. I real kind of the logic of what I did there. So what I did was, no, Summer, ask away. No.
It's,
So what I just did there, right, the idea was I took this three-dimensional object, I turned it into a flat bottom, right, then you get the hypotenuse of that, and then I use that in the height. Yes. And this is like any of those triangles that you probably had to solve in grade 10 or whatever, where you have multiple triangles put together, right? So it's, except it happens to be in 3 dimensions, that's the only difference. All right, let's crank it up to 21 here for a sec. Yes, go ahead.
Why did you ever square on 164
Oh, because the square root of 164, right? Because this, if you do, because basically this is the same as 164 to the 1/2, right? That's the square root is. And then if you square that, 1/2 times 2 is just 1, so that's just the same as 164.
So
So it's square. Yeah. You can use decimals if you want, yes. You can if you want to. I just didn't have a calculator with me, so I did with numbers.
Also, if, God forbid, we had to do the 4th dimension, we would need 3 triangles.
Yes.
So,
We'll leave it out for right now. I don't want to scare people. Yeah, I don't want to scare people.
is there any 4 dimensions?
Not today. I don't want to scare people. I don't want to scare people. Not today. Goodness me. I don't want to scare people today. Okay, example 2. All right, here we go. From the top of a building. A fighter looks down at 2 fighters. gonna stop the video here. I'm gonna photocopy it. Oh, yes, they're all